what about 5G in my building? And I felt like we have to really separate the low, mid, and high band technologies because it makes a real difference. You didn't have to do this in the 4G world. I mean, you had a range of frequencies, again, 7 to 2100 megahertz. They were all relatively available in your building if you had a building that didn't block the RF signal, or they all relatively weren't available. If you had a high, say a gold or platinum LEED building, probably didn't get any cellular signal. So now it's different. So I'm going to tackle the low band and then the mid and the high band in separate slides. And so my first point is, if you're already getting good cell service in the low band now in 4G, you'll get good cell service with 5G low band when it switches to NR. The same frequencies, the same physical characteristics. Now, what you'll have to anticipate is if you have a DAS already or a booster, you'll probably have to replace the electronics. There are one or two manufacturers that are actually selling a 5G software upgradable 4G solution now. So if you were going to deploy today, you'll see my recommendation later. I would definitely deploy one that is software upgradable, doesn't have to be forklifted. And then the people who make the decision about when it converts from the LTE to the NR technology will not be the building owners, it'll be the carriers. So at some point AT&T will operate, we don't know exactly what that transition plan looks like yet, but make up, the 2100 megahertz, they may operate LTE and NR in conjunction for a while in parallel, or they may just decide to turn down LTE one day and turn up NR the next. We don't know yet, but we'll see that conversion over the next 2 or 3 years. It'll happen, in different cities at different times, and they're all regionally controlled. Right now, you already see T-Mobile saying, hey, we're going to roll out 5G NR on their 600 and 2500 megahertz solutions. So that's where you'll start first, and then they'll go back to the traditional the LTE frequencies. And so, again, roughly in 2 or 3 years, you'll see all of that roll out. If you're buying a cell phone now, it has 5G chipsets in it. In fact, the Samsung Galaxy, I think S20, only has you can't get it without 5G chipset. You don't have the option of only buying a 4G solution. And there will be some real increase in performance that comes with that transition to the new technology. You get better multiplexing. You'll see about 100 to 200% increase. Now, that's nothing when you think about the promises of a 10,000% increase that 5G is making. You get that by going to mid-band and high band. So as I pointed out, mid-band covers CBRS, which you see is in the 3,500 megahertz spectrum. By the way, Katie, I know, offered if anybody wants to interrupt and ask questions. I shouldn't have used the word interrupt. I love taking questions midstream, so feel free to do so. You don't have to wait, but you're welcome to wait as well. So not all of the mid-band is currently available like CBRS, but this is a unique and unusual licensing structure. Some of you know about it, some of you don't, but it's effectively a certain bandwidth of frequency is going to be available to 3 different license holders all at the same time. So there's a complicated back end that goes around sensing which of the you have 3 different priority levels of who gets to use that signal, and then kind of how that all gets divided out. Plus, it's a shared spectrum between the different carriers, just that CBRS band. So unlike other frequencies that AT&T just owns this one particular band and Verizon owns that particular band, CBRS won't be owned by anybody. It'll be licensed first by the Navy, believe it or not, that's the primary license holder, and then by the carriers, and then which is going to be called a general access license. That means you can operate a CBRS network in your building that is private. So it's a private LTE network. Some of you have heard of this, some of you are already anticipating it. What does that do for you? Well, I'll give it 2 examples. We have of course, COVID's interrupted everything, but we have a very large corporate client that has never been willing to put cameras, security cameras, surveillance cameras on a Wi-Fi network because of security reasons, but they are exploring putting it on a CBRS network. Now, that makes the possibility of adding those cameras in different places on a big campus environment a whole lot simpler. You still have to get power, but tying back to the network now becomes virtually trivial. The a CBRS dongle today is maybe $50. And the second is we're working with a large gaming customer, and they've been wanting to be able to shift their gaming facilities to the games. And COVID actually has accelerated this to where, like, for example, they're talking about having slot machines that are 6 feet apart. Well, that mobility of being able to move the machines means they really would like to not have to wire their connectivity. And the Nevada Gaming Commission has never previously allowed any game to be on a Wi-Fi network, but they have approved CBRS. So you can see that CBRS LTE security significantly increase over Wi-Fi, which means that applications where you had concerns about putting it on Wi-Fi for various reasons, bandwidth constraints or security, are now alleviated in CBRS. That's the attraction of the CBRS network. It can be used by multiple parties, and the carriers will also use it, as I noted, because there are 3 levels of licensing, and we're actually working with some customers today who have some applications, like I mentioned, that are very excited about CBRS. And you'll see in just a minute, I'll talk about kind of, well, what if I tried to do both private and commercial cellular services on the CBRS network? So I'll cover that in just a moment. But here's a couple of use cases for what you could do. I gave you 2, but you can see pretty much anything that you want to connect that you previously thought was the connectivity part was really difficult. We're working with a very posh country club in Florida, and they want to add cameras, and these cameras are 4,000 to 7,000 feet away from where their video management system for their surveillance is located. So you got to connect it to a network somewhere. They don't have any network connectivity. So they were looking at like trenching fiber for 7,000 feet, or using traditional point-to-point wired connections. And we're talking like we were pushing into the 7-figure range with both those solutions, whereas a CBRS solution is a low 6-figure range. So you're probably about an order of cost lower using CBRS than some of those traditional methods. Really anything like that. Okay, moving on to high band. So this is, I mentioned briefly, I didn't really cover it in the mid-band, but no mid-band signal nor high-band signal will penetrate from the outside to the inside. It's why, by the way, that you can have a 3-tier licensing structure with CBRS, because the AT&T can be using that signal outside the building to deliver cell phone calls, and inside your building, you can be using it for a whole different purpose, because the building envelope creates an effective barrier between the two. That just gets even worse in the high band. So the higher the frequency, you get more data capability, but you get less penetration of structure. In fact, you can block a microwave signal by walking in front of it. So supposedly I'm Avery here on this presentation, but if I'm broadcasting some microwave and Avery walks in front of it and I was trying to broadcast a tray, well, I just lost my signal while Avery meandered through our little walkway there, and that's how little propagation characteristics this has. So any kind of mid-band or high-band communications in your building will have to be done through a system. You'll never be able to have it just leach in from the outside like you can in some environments today with cellular. That's probably the biggest news with respect to a building owner. We'll talk a little bit about the implications of that and how to kind of plan for it. With the mid-band solution, especially the lower frequencies, the CBRS frequencies, there is a possibility to use the same network layer that you're currently using for 4G. So all you would have to do is add electronics. I'm not saying that that's true everywhere, but there are, for example, products today that are rated to all the way up to 3,600 megahertz. So you could potentially, if you're looking to the future, put in one network layer and cover all of the low band and some of the mid band frequencies on one network layer, one infrastructure layer. That's not true for the high band. High band is going to all be fiber. It's all going to be remote, located out on the edge, and so you're going to have to put in an all new layer. So at the very least, you'd have to have 2 and possibly 3 network layers to accommodate the low, mid, and high band 5G in a building. I mentioned here that if you've done a fiber to the edge solution, either a 4G DAS that's fiber to the edge, or you're doing something like GPON. Symphony does a lot of GPON, for example. It may be beneficial to you. The problem is, I can't tell you, because the predictive models right now for 5G aren't even finally nailed down. So I don't know where those 5G remotes are going to have to go in your building. I have a pretty good idea, but I don't know exactly. And the software that models that doesn't have exact parameters for it. So they may or may not be helpful to you that you've got fiber to the edge because you got it on the wrong side of the hallway or whatever. I'm just telling you, it's not a guarantee. It's not a slam dunk. Now, here's the thing that should relieve your mind if you're thinking, oh my God, that's just so much cost I got to anticipate. It's very unlikely that you're going to do 5G in anything other than dense environments. So if you're looking at, let's say, a mixed use environment where you've got a apartment high rise, you've got a hotel, you've got a commercial office space, I would venture to say in the next 10 years, you probably wouldn't overbuild more than 10 or 15% of that total footprint with the 5G millimeter wave, because you're just going to do it in the ballrooms and the meeting areas, and maybe you've got a food hall, although what that looks like after COVID, I don't know. But you're not going to be doing it on the residential hallways, where you have tenants or guests staying, because there's just not a need for that kind of density and throughput and latency. You'll never be able to cost justify it. So you're only going to, in building, you're only going to overbuild 5G in those large common areas. Just for fun, I thought I'd tell you about propagation of 5G, because one of the big issues with the high band was people thought, well, if Avery can walk in front of my signal and block it, that's not going to be very effective. How's it going to work in a building? And these are basically the 5 different reasons why these last 5 bullets: millimeter wave, near line of sight reflectivity. I mentioned MIMO, 128. It went from 2 to 4. I've seen 8x8 MIMO once in my life, and we're going to be looking at 128 MIMO in 5G high band. I don't need to, you can read all of those. But what that amounts to is a surprisingly effective ability to propagate 5G millimeter wave inside a building. Better than a lot of people expected. And so there was a lot of skepticism for a long time. So you can see that kind of XS there at the bottom, that's the X is the location of the remote, and S obviously stands for source. You can see that by throwing a whole bunch of signal out and bouncing it around the room, it actually does penetrate pretty well. And I'm going to show you a real life solution here in just a second. But that's kind of a diagram that illustrates how a millimeter wave solution will actually cover an entire room. And then I'm going to show you, so there is one commercially available technology today, and this is an actual representation. So on the right, you have what the model predicted would be the coverage. And if you're not used to reading IV wave heat maps, you don't want dark blue. You're getting marginal with light blue. You love red, orange, yellow, and green. And so you can see the model predicted on the right very closely to the left. Those little dots are measuring actual. So to the right is the projected, to the left is the actual, and you can see you've got a few dark blue dots there over on the left side of that square, but really it propagates pretty well. And so you can see it, go back to the propagation map, if you see that red area, the little arrow and the little, it's like a splitter right there, that icon for a splitter, that's one remote. You can see if you put another remote up on the top left part of that room, you'd have great coverage. That's a 20,000 square foot room. Now, when people were first talking about microwave, they were talking about maybe 1,000 feet per remote. Would have been unbelievably expensive at that kind of density. You can see here, you're looking at maybe 10,000 feet per remote. Well, that's pretty good. That's pretty comparable to current DAS solutions. And so because of those 5 technology reasons that I listed before, that basically just thinking that signal is bouncing around everywhere. And if you bounce a whole bunch of those signals around, turns out you cover the whole room. Now, I will point out, now that I've passed that slide, we can't include that slide in this deck. That was a proprietary slide from the one manufacturer that actually has a commercially available 5G microwave solution. We were allowed to show it, but we're not allowed to give it to you. So it will be excluded from the deck. I apologize, but that was just the rules of the game. This stuff is brand new, and so they're guarding some of their proprietary technology. All right. now we get to kind of the rub. I initially had this titled, okay, my head hurts, break it down. Katie felt like that wasn't great marketing. She probably knows better than I do. My head hurts, and I've been immersed in this stuff. But it sort of boil it down to, I'm sitting with a building, either I have an existing building, I've got a building that's in construction, I've got a building in planning. You know, those are different profiles. What do I need to be thinking about? So I tried to kind of break that down into these different helpful pieces of information, and I think this is the rub for you. You know, if you have 4G now, and it's coming in natively, you'll have 5G in the same frequency ranges. If you got an LED certified building, a LEED certified building that you're putting up, you're not going to have good signal. We just routinely see that that's the case. And of course, for the mid and high band, 5G will just make it a whole lot worse because you won't get any signal. A lot of people ask me about the cost, and we recently were working with a customer, and they said, hey, we've got your DAS bid, and we've got a competing DAS bid, and they're a lot lower than you are. That happens. I said, okay, that's fine. I gave you the technical specifications of what we're providing. What are they providing? And they said, I didn't know. It just says DAS and then listed an amount. Then, I had to basically try to sort of sigh and think to myself, I know this is what's going to happen over the years, is people are going to take advantage of the fact that DAS, when it used to mean a sort of commonly defined thing. So you'll see the third bullet under cost. Today, if you were opening a building today, we'd recommend a 3-band SISO, single in, single out, 4G DAS solution, and we can do that all day for less than $1 a foot. There are unusual circumstances. You have an historic building, don't take it to mean everywhere, but real consistently, we're well under $1 a foot. Well, we're working on a very large airport solution right now. You may have heard of this airport, and it may be located close to our headquarters. And just in the low band, we're looking at 9 bands. So in that 600 to 2600 range, we're talking 9 bands in that, just in the low band range, and then adding mid band and high band. So we're explaining it's $1 a foot for a 3-band SISO solution, but you add 9 bands to the low band, and then you start adding mid band and high band. I mean, it's the sky's the limit. I don't know. We don't even know what things are going to cost in some respects. And so 8-10 years ago, people were paying a lot of money for DAS, and then it's dropped significantly. Well, it's going to go back up again. And what I'm going to suggest is, I don't think you necessarily want to go, oh, great, I got to allocate $5 or $10 a foot for DAS. I think that we're going to enter an environment where you have to be very careful and selective about knowing what you need, and only taking what you need, and not trying to just pile on everything that the carriers would want you to have. So there's going to be a whole lot less ability to take 2 DAS quotes and assume that they're apples to apples. You're going to have to spend more time qualifying exactly what I'm getting. So imagine if you had a hotel and I said, hey, your audio-visual system is $150,000. Well, the first thing you'd ask me is, well, what does that include? How many TVs do I get? How big are they? How many rooms are you serving? What kind of control am I getting? You're going to have to do the same thing with DAS now. You have to ask a lot of questions. I don't anticipate a whole lot of subsidy going out from the carriers, from the WSPs, but I'll note, as a counter argument, that as part of the deal for getting Sprint, T-Mobile, and Dish Network now have a combined spend commitment to the FCC of $40 billion. They haven't said whether they'll spend it outdoor or indoor, so I don't know if it'll be available for buildings, but there's going to be a lot of money dropped on building out 5G in the next 3 years, and we're already talking with those carriers and working on prospective projects. So the possibility exists that there will be some money. It's going to typically be bigger projects. They call it over 1 million feet, 2,000 to 3,000 people moving through. And then the kind of last aspect of that I wanted to touch on, and this is a little bit technical, but it's one of the most difficult parts of DAS, is actually getting connection from the carriers. So there's some really cool technology development on that side. It is related to 5G. That's why I bring it up. So up until this point, you needed a very large, cumbersome, proprietary piece of equipment built either by Ericsson or Nokia. This year, carriers will start rolling out software-defined solutions that are a server in a rack. So not only will it become less expensive and easier to deploy, but you'll go from needing 6 or 8 racks for those, what are called base terminal stations, Nokia and Ericsson equipment, to 1 rack for all of your carriers, because they'll each have a 2 RU server, and that's all you'll need. So I'm real excited for the sake of my customers. It's going to be a lot easier to get carriers to now connect to your DAS, whatever your DAS looks like.